One of the more interesting problems for chess aficionados is the Knight's Tour. We're going to take a peek at solving a question regarding can the chess piece called the knight move around an empty chessboard and touch each of the 64 squares once and only once. Now we're going to use a brute force approach, which means that we will just use the random number generator to pick the steps for the Knight's Tour. We will allow the user to pick the starting row and column. As far as moving about the board in his 2 to the left, 1 up type of walk, we will let the random number generator choose the next step. At the end of the tour, we want the program to provide the following: the starting location that the user chose for the knight to start the tour, the number of steps the knight took, and this will be easy because we can track the steps and put them in the grid, and finally the knight's final destination. Where did he end up? What row and column? If we're going to represent a chessboard, we want a 8x8 grid that might look like the following. Here's my 8x8 grid. Let's just go ahead and put the knight in location row 4, column 5. Given the knight is starting in row 4, column 5, I've marked his 8 possible moves from that location. So we can use a two-dimensional array, make it integer, to represent our 8x8 chessboard because we're tracking his steps around the board. I just happen to put the knight a K in there to represent where he's at currently. But if we were tracking his path, we would actually put a number 1 there for his first step. Okay, so let's look at this. We have 2 steps up, 1 to the right for step 1, 1 step up and 2 to the right for step 2, 1 step down and 2 to the right for step 3, 2 steps down, 1 step to the right for step 4, etc. How could we represent steps that the knight could take in terms of programming code? Well, we could use a two-dimensional array. The first dimension could correspond to his offset in terms of rows, and the second dimension could represent the offset in terms of the column. So let's try that. Let's see if we can list those 8 steps in terms of offsets for row and column. Okay, so the first one we need to do what? Minus 2 rows plus 1 column. For the next step, we need to do minus 1 row plus 2 columns. The third, plus 1 row plus 2 columns. For number 4, plus 2 rows plus 1 column. Number 5, and that's plus 2 rows minus 1 column. Number 6 is what? Plus 1 row minus 2 columns. Number 7, now we're going back a row, so this is minus 1 row minus 2 columns. And number 8 is minus 2 rows minus 1 column. So we could store these offsets in a two-dimensional array that has 8 rows and 2 columns. Then we would randomly select 1 through 8 and try to take the step based on the offsets for row and column. So let's just see how that works. Given the knight is in location 4, 5 right now on the grid, and we randomly select 5, we would add 2 to the row and subtract 1 from the column to move the knight to location 5. But what if the knight is up here? Now how many moves can the knight make? Well, we see that if he tried to move for step 1, which is minus 2 rows, he's off the grid. How about step 2? That's minus 1 row plus 2 columns. So that he could do. And he could move for step 3, which would be right here. And he could move for step 4, which would be right here, plus 2 rows, plus 1 column. But he couldn't move for step 5 because that's plus 2 rows minus 1 column, which would be off the board. Move 6 would be off the board, move 7 would be off the board, and move 8 would be off the board. So if our knight were here, he couldn't take step 1, but he could take step 2, which would put him here. He could take step 3, and he could take step 4. Well, what if we put the knight down in this corner? Now what steps could he take? Step 1 is minus 2 rows plus 1 column. So he could take that step. Step 2 is minus 1 row plus 2 columns. So he could take that step. But are there any other steps the knight could take? No. So we see we have a complicating issue here. Depending on where the knight is on the board determines how many possible steps he could take. In video 2, we'll consider a way of managing this that alters our data structure for the board to make our processing more simple. This is a very common technique in programming. By the use of data structures, we can simplify the code.